Pre-flight 101, the course that will give you wings. 5. Aircraft systems and structures. 5.2 Instruments, Communications and Avionics. Hello again, this is Jose. We are back at this chapter with Instruments and Communications. In this chapter we're going to be learning about the instrumentation and avionics you can find in the cockpit of the CESSNA 172. As we've already said before, the instrumentations and avionics change substantially from one model to another. Okay guys? Instruments by definition are basically a series of gauges presented to the pilot in the cockpit to give a reading on information such as airspeed, attitude indication, altitude indication, and other parameters such as the engines or the electrical system. They can be found in a digital format or in an analogic format. However, the indication is always presented in a similar way. Here we can see a couple of instruments. Both of them indicate speed. At the back of the instrument we can find a colored scale, right? Yellow, green, and a red line. Really easy. Green means good, yellow means caution, and red means that something is not working as it should. At the outermost part we can see the numbers corresponding to the parameters. In this case 80 knots, airspeed, okay? And in the front we can appreciate a needle. The needle is going to be pointing at the current value of the parameter that is being measured. In the electronic or digital instruments, it's exactly the same. We have the same colors, red, yellow, and green. We have that indications with numbers, up and down. We have from 90 to 130 in this case. And we have that arrow or that needle that is going to be pointing to the current parameter that we're going to be taking a look at. Maybe the object of this course is not to be discussing how the instruments work. We're just going to be taking a brief look at how instruments work, how to read them, how to read the most important one, how do we use them, okay? I'm not going to be focusing on how the pressure is measured out of the airplane to give you the speed. I'm just going to give you a couple of clues on that, but the important thing is that you learn how to use the instruments. Now, this is the cockpit of the conventional Cessna. To locate our instruments, we are going to divide the cockpit in sections. The first section, the basic T or basic instruments, these are the most important instruments in the cockpit. They give real-time vital information about the energy state of the airplane. These are the airspeed indicator, the altimeter, the horizontal situation indicator, and the artificial horizon. Very close to these we have the secondary instruments. Okay, secondary instruments are coming up in yellow right now. These two, the vertical speed indicator and the turn coordinator, are not basic, but they help us a lot when we are flying, as we will see in further lessons. Depicted now in green are the radio panels and navigation instruments. We will see what they are for and how to use them soon. That is an RMI. We have a course deflection indicator, and we have another RMI right there. The first one is fitted with an ILS, but this is all radio navigation. We will see something about this after. These are the radio panels. We will see how to use them and how to operate them in the last part of the next of this section. And these last systems, in yellow, the system gauges and engine tachometer. These are the instruments we use to constantly monitor our instruments or to look for faults or malfunctions. That is the tachometer. We are looking at the RPMs. That is the rotational speed of the engine. Okay, one of the most important parameters. That's why it's in front of us. And those are all the gauges. We will see them especially in the operations or the procedures section, because we're going to be using them for a lot of things, for a lot of checks before departure. So we're just going to be learning how to use them. Now we're going to be talking about the basic T. In the basic T, we can find these four instruments. The first one is the airspeed indicator. The airspeed indicator indicates the relative airspeed of the aircraft with the airflow. All right. As you can see in the diagram, we have a green scale, that is the normal speed. A yellow scale, this speed is only for certain conditions when there's a smooth air and other conditions apply. And this red line is never exceed speed. We should never fly intentionally above that speed. We should avoid to fly above that speed because that's getting close to the structural limit of the aircraft. Okay. Then we have the needle. The needle is going to be moving around with us to show us the parameters. And then we have this white ladder right here. This white ladder is going to show us the flap operation range of speeds. Okay, so in this case 100 would be the maximum flap speed and 60 would be the stall speed with flap. This is not the instrument of a Cessna 172, but it still gives us a pretty nice clue of how to operate these systems. The second system we're going to be taking a look at is the artificial horizon. Okay, basically an artificial horizon is the shape of an airplane fitted in the center, and an artificial horizon, as I said before, that is going to be rotating in the back. This is going to give us a clue of what the pitch attitude of my aircraft is when I don't have external references. The most important parts of this instrument are these lines right here indicate the bank angle. When this pivot, this orange pivot right here is up here, it means that there's no bank is 0. Here would be 10 degrees, another 10 degrees, another 10 degrees. So this is the standard IFR or standard turn, that is 30 degrees. We shouldn't be turning more than 30 degrees when we are flying stable or when we are flying standard. Okay. The next one is 45 degrees. 45 degrees is already considered a steep turn. Okay. And the next one is going to be coincidental with the 90 degrees turn. Okay. Depending on the pitch and roll of your aircraft, this instrument is going to give out some reading or another reading. Okay. Then we have the horizon. Then you can see the pitch degrees. Okay. This would mean 10 degrees of pitch up, 15 degrees of pitch up, 10 degrees of pitch down, 20 degrees of pitch down. This is more for instrumental flight, but it can always be a help. I will teach you how to fly with pitch and power in the operations section. For now, just take care with this instrument. It is powered by vacuum. Okay, it's powered by vacuum, which means that it needs the engine to be running to work. Okay, we will see this when we talk about engines, when we talk about the miscellaneous system, about the vacuum system. But basically, keep that in mind. Okay, we need some vacuum, we need some engine movement for this instrument to be working. The next one is the altimeter. The altimeter basically senses the outside pressure of the air. Okay, the pressure of the air outside the airplane decreases, as you guys know, when we climb. The more altitude, the less pressure. So this instrument is able to show the altitude above the mean sea level when we give it the total outside pressure. Okay. Most important thing about this is that we have the Kalman's window right here. Here we can select the Q and H. Okay, the Q and H, or the Q&E. Basically, this is to give a reference to the system. We will see this also in the procedures section. Don't worry about it. Just if you don't know how to work with these instruments, I highly encourage you to look for some kind of manual and so look for some kind of information on these systems, because it's really important. Okay, these 4 systems are vital. You need to know how to use them, and you need to know what the most basic, or let's say this way, basic or normal failures of these instruments are. Then at last we have the horizontal situation indicator. Okay, the horizontal situation indicator is going to give us a heading. Okay, this airplane is going to be rotating and it's going to give us the heading north, heading south, heading west, heading east. We don't need this in visual flight, however it might be a help, because as you might already know, the magnetic compass is not the most precise. So to sum, we have these instruments that might be digital or might be analogic. Here we're gonna see the basic T in the digital way. For this we're using the Garmin 1000. Okay, this is a representation of the Garmin 1000. The Garmin 1000, as you guys might know, is one of the most common general aviation class cockpits in the world. So we're gonna see how the basic T is presented. If you want, you can take your drawing from the documentation section. You have the CESSNA 172 panel, the instrument panel. You can take it and you can compare what you see in the panel with what you actually see in the Garmin 1000. So the first thing you see is the airspeed indicator. The airspeed indicator is a tape. This is called a speed tape. Okay, it goes up and down instead of a circle like in the analogic ones, but the principle is still the same. Green stands for good range of operation. White stands for flap speed, maximum flap speed, and stall flap speed. The numbers stand for the airspeed in knots. Okay, and this big number right here pointing in an arrow is the current airspeed. Good thing about this instrument that we didn't have in the basic ones are the speed bags. Speed bags are these things that we can actually select them. We can select the Y speed, we can select the glide speed, and we can select the VX. This is to just basically to remind it to yourself. Okay, in order to get the best situational awareness, you don't have to be thinking about, hey, what was my VX, what was my best glide speed. No, you have it in your screen. You don't need to do anything or think about anything. If you push this button right here in time and reference, you can change these speed bags. We will see this after. Also, you have a computation of the true airspeed. This would be indicated airspeed and this would be true airspeed. We didn't have that in the other instrumentation, okay, because this needs temperature and a complex computer to be working. Now we have the altimeter. The altimeter is also a tape, okay, an altitude tape instead of a clock that goes around. The thing is exactly the same. We have all the altitudes presented in a tape. If you go up, the numbers are going to be going up. If you go down, the numbers are going to be going down. Good things about this, you have a selector. Okay, you can select the altitude you want to maintain. This is going to give best situational awareness. The selector is going to be also displayed there. So if ATC tells you, hey, climb to 4,500 feet, you just have to select it. To select it, you're going to use this knob right here. You're going to select it, and that way you won't forget. Here you have the Kalman's window. The Kalman's window, as I said before, is to give the reference to this system, to give the QNH or the QNE to the system. Here you see the word barrow. Here's how you change it. With the outer knob, this outer knob, turning this outer knob, you're going to be choosing the QNH, okay? This way you give the reference so you can always fly over the correct altitude setting. Now, the artificial horizon might be one of the biggest changes from a digital cockpit to the normal or basic instrumentation. In the digital cockpit, as you can see, the whole screen is an artificial horizon, right? You can see the ground is all the brown part over here, and the sky is all the blue part over here. This is your airplane, okay? This is the sign of your airplane that is always going to be in the same position, and behind the whole screen is going to be turning with it. We will see this in the operations section or in the procedure section when I will give you a simulator on how to depart, how to land, so you're going to be seeing this screen a lot. Just like in the basic instrumentation, you have the settings, right? The ratings of pitch. You have 10 degrees nose down, 20 degrees nose down, 10 degrees nose up, 20 degrees nose up. And you also have here the turning scale, right? So in this case, we have 0, 10, 20, 30, 45, and here we would have 60 degrees. Okay, 90 would be around here, so that is the 60 degrees mark. Good thing about this is better situational awareness. Now, that is the horizontal situation indicator. As you can see, it's basically the same as the other one. There's an aircraft in the middle. There are the different headings around. The big things here are the heading is going to be marked up there, so you always see a number of the heading you're actually maintaining. This is going to allow you to maintain a precise heading for a longer time. You also have this blue bag. A bag is, as I said before, with the altimeter is the same as this one, just to select which heading you want to keep, and you can use it with this knob right here. Turning this knob is going to be turning this selector, and this way you're going to select which heading you want to maintain. Imagine ATC tells you maintain heading 190. You can select it and then turn, that way you won't forget. Another big thing about this horizontal situation indicator is that the radio aids, you can see here the nav1, that is the Papa Alpha Echo VOR, it's included in the HSI. You might remember from the previous slides that the HSI didn't have radio aids, that the radio aids were to the right of the cockpit, pretty far from the HSI. With this design in the digital cockpit, we make sure that the pilot can look at the HSI and look at the radio aids at the same time. Okay, we don't need to turn our face towards the right side of the cockpit in order to be seeing the radio aids. We have everything at the same point. Now, the next part we are going to be seeing are the secondary flight instruments. Okay, we're going to be talking about the vertical speed indicator and the turn coordinator. So now, what we have here are the secondary instruments, as we were saying, the turn coordinator and the vertical speed indicator. Let's get going with the turn coordinator. So the turn coordinator is this instrument you see right here. And I want you to take a look at it. It has two parts. The first part is this turn indicator, and the second part is the turn coordinator. So this instrument is also called the stick and the ball. Okay, stick would be the airplane, and the ball is the ball that is right in the middle of the turn coordinator. Let's go part by part. So the first thing we read here is that this is no pitch information. Okay, so that the plane is here is turning to the left. This doesn't mean that the airplane is turning to the left at 30 degrees or 50 degrees or 10 degrees. No, it has nothing to do with this. This instrument right here is only going to give you roll rate. Okay, the heading change rate. So if you are turning at 3 degrees per second, which means every second you are 3 degrees of heading more to the left, this indicator is going to be here. If it's less than 3, it's going to be here, and if it's more than 3, it's going to be here. If you're going to be doing a standard turn, you want to do a 3 degrees per second turn. So you want to keep it there. There are different ratings, okay? I just said 3 as a general number, but there are different settings. The only thing you need to know is that this is no bank information, okay? Anyway, if the wing is here, it means that you are not turning. It means that the aircraft is not turning anywhere. And if the wings are turning here or here, it means that you are turning to the left or to the right. That's pretty easy to understand. Now, this ball right here, I'm pretty sure you guys are familiar with this ball right here. This looks kind of that little thing that you might use when you want to place a table at home or a drawing on the wall and you don't really know if it's straight or not. Well, this works the same way. We need to know if we are turning coordinated. What does turning coordinated means? Turning coordinated means that we are getting the best change of heading for the role we are using. So for changing heading, we are going to be using the ailerons. So we are going to be banking, and we are going to be using the rudder. Okay, we are going to be using the pedals. So to know if we are using enough or too much pedal, we are going to get this ball. And now I want you to think about a sentence. The sentence is step on the ball. So if the ball is here, if the ball moves to the right, step on the ball. Which pedal are you going to push? Exactly, the right pedal, because you want to step on the ball. When you step on the ball, this is going to go straight to the center again. Now, imagine the ball moves to the left at some point. Again, step on the ball. What am I going to do to move the ball to the center again? Exactly, left pedal. And that's how easy it is. These two instruments are not too useful for VFR flight. However, they're going to help you improve the performance of your aircraft, because if the ball is centered, the aircraft is going to react way better and the power of the engine is going to get used way more efficiently. Now let's take a look at the vertical speed indicator. The vertical speed indicator is basically two altitude indicators or two altimeters combined, and they compare each other all the time. So imagine the altimeter 1 says we are at 100 feet. The altimeter 2 says we are at 200 feet. The altimeter 1 then says we are at 300 feet. Well, this means that you are changing your altitude. So the rate of change of altitude is called the vertical speed. It's the speed at which you are climbing or descending. In this case, it's measured in feet per minute. If the needle is here, that means that you are flying straight and level. You're not climbing, you are not descending, you're keeping the same altitude. If this is going down to 500, for example, this means that you are descending at a rate of 500 feet every minute, okay? And if it goes to 5 in the upper side, it means that you are climbing at a speed, at a rate of 500 feet per minute. Every minute you are 500 feet higher in the air. This in IFR flight is basic. In VFR flight is just maybe for you to learn how to fly stabilized and so on. But anyway, these two systems are secondary instruments and they are located next to the basic T. Let's take a look now at where they are located in a digital PFD like it is the Garmin 1000. So the vertical speed indicator is going to be right next to the altimeter. That is really good for situational awareness because we don't need to be looking at two different systems. We just look at one screen and we are getting altitude indication and vertical speed indication. That's going to make us able to do corrections way faster and fly the airplane way smoother. The scale is the same. We have a needle that is marking you at this moment minus 300 feet per minute. We have the minus 1000, the minus 2000, the plus 1000 and the plus 2000 max. These might change depending on the kind of aircraft, but the functioning is exactly the same as it can be in the speed indicator or in the altitude indicator. Now, the turn coordinator. This one is really hard to see, okay? I'm gonna ask you to have some faith in me, okay? I need some faith here. This turn coordinator looks nothing like the older one, but the working principle is the same. So, we have this big triangle right here. This big triangle is like the airplane in the older models, in the basic models. It's going to show us if we are turning to the right or turning to the left. But this one is a bank indication, as we said before. Okay. Now, that little square right there, that little square is what is actually the turn coordinator, the ball. This square right here is going to move to the left and is going to move to the right. Okay. Let's do the same example as before. If the square moves to the right, what do I have to do? Step on the ball. That means I need more right rudder. If I push the right rudder, the ball, or in this case, the square, is going to go back under the triangle. And that's exactly what we want. We want to center that square under the triangle. Now, the other example. What do we do? Exactly. You're going to be pushing the left pedal. Why? Because we want to put that ball right in the center again. So push the ball. Step on the ball. Step on the ball. Okay, this is really important to get the best performance out of your airplane. And now you may be asking, well, Jose, you were saying that that is not a pitch indicator. So where is the roll indicator? Where is the stick? Where is the roll indicator on the screen? The roll indicator is going to appear right here. Here, a purple or magenta line is going to appear to the side that you are turning to. As you can see here, there are two lines, 1, 2, 1, and 2 on each side, and that's going to be the exact same as in the older models. Okay, this magenta line is going to move here when you're turning, or when your heading is turning to the right, and it's going to turn towards here when your heading is turning to the left. It's going to do the exact same thing, but the indications are a bit different. In the following slides, we will take a look at the systems-related instruments for the CESSNA 172. The first instrument we can see here is the tachometer, or the RPM measurement. Okay, this instrument is going to give us a reading on the rotational speed that the engine has. So basically, we just have to read RPM times 100. This engine right now is marking 500 RPM. All this lower range is a nice range for operation. Okay, it's not green because it's not safe for takeoff. In this case, only the green level is set for takeoff. When we are about to take off, the needle should be pointing on the green. Okay, that's the most important thing. Just like in the airspeed indicator, we have this red never exceed line. This means that this engine is designed for having a maximum rotational speed of 2,700 RPM. Okay, that's our maximum rotational speed. There's nothing really much to explain here. It's not that difficult, so we're just gonna move on to the next ones. The temperature, oil temperature, and oil pressure indicator. As we will see in the procedures section, oil is one of the most important parameters to monitor. Okay, an engine without oil might break apart in a matter of minutes. So we want to take care of our engine by taking care of the temperature and the pressure. Okay, so whenever we start the engine, the pressure should be going up. So the moment we start the engine, the pressure has to go to the green range. Okay, the green range may vary. We are going to see the green ranges of the different CESSNAs in the limitation section, but whenever we start the engine, we need to check the oil pressure. That's the most important thing. Now, the oil temperature. Well, if you guys have a car or drive a car, you might know that oil temperature takes a bit to warm up. Same happens with airplanes. The moment you start your airplane, obviously the oil is going to be cold. So the line is not going to be pointing towards the green. But before we take off and before we do our engine run-up, the engine run-up is just testing the engine, we want to have that good oil temperature. Okay. Also, we have these red never exceed lines. If we ever see that the oil temperature is above 245 or that the oil pressure is above 115, that means something is not working properly and we should be running an abnormal or an emergency checklist. The next system we're going to be talking about is the vacuum indicator and the amperometer. As you know, the amperometer is a measurement of electrical discharge, to say it somehow. It's not the voltage, it's the intensity of the current, okay, the amperes of the current. Also, we have negative indications, we have positive indications, and we have zero indications. Positive indications means that the system is loading. Negative indications means that the system is discharging. Okay, you just have to keep this in mind for now. The vacuum, as we said before, the artificial horizon and certain instruments need vacuum to work. They need a current of air that produces a vacuum that is produced by the rotational force of the engine. Okay, and in order for these instruments to work, we need to keep this vacuum in the green range. In this case, is from 4.5 to 5.5 inches. Okay. We also have some suction gauges that is basically the same as vacuum. It's the same concept, just the different words. We have the amperometers in another different kind of gauge. Then we have the fuel quantity indicator. There's nothing really interesting about this indicator. You just have the left tank and the right tank. In airplanes, we usually have more than one tank for redundancy and because we have two wings and it's easier in terms of weight balancing. So as you guys know, this is the same as in the car. F stands for full and E stands for empty, okay, in terms of quantity. And the last one is the EGT indicator and fuel flow indicator. EGT stands for exhaust gas temperature. All right, is the temperature of the gas that is coming out of the exhaust. It cannot be too high, but If it's too low, it's also not good. We are going to see in the procedure section how to lean the mixture by using the EGT. For now, just remember that the red line means that it's a never exceed. That is the limit. If the EGT is going over the red line, there is obviously a problem. Fuel flow indication. It indicates the quantity of fuel that the engine is burning at a given time. So, from 0 to 11 is a normal fuel flow. That means that the engine is burning normally. More than 11 until 19 means that the engine is not burning normally. Imagine we are burning 18 gallons or 15 gallons. Does this mean that the engine is broken? No, it doesn't. It means that it's not normal. But imagine you are doing maneuvers. Imagine you are doing full power for some reason. You are just doing steep turns with full power. Then, of course, you're going to burn more fuel. This system is just telling you that if you are trying to do a cruise in that situation, you're burning probably much more fuel than you wish for. These are the instruments, the engine or system instruments in the Cessna 172 fitted with Garmin 1000. This section right here is the engine section. Okay, we are getting a lot of information there. It's basically the same as the basic instruments, but we get them all at the same place, which makes it way easier to check the parameters and to detect a faulty system. Let's start with the RPM. The RPM is exactly the same. It goes from 0 to the maximum, and there has the green range that is for takeoff. We have already talked about that. Good thing here, if the RPM goes over the limit, the RPM number is going to turn red, flashing. Okay, this number right here is going to be flashing, and this is going to be telling us, dude, there's a problem. The RPMs are too high. You need to fix something. The fuel flow in gallons per hour. You also have the green line. We have also discussed, and you have the other line. And yeah, basically it's gonna tell you the fuel flow. This is the oil pressure with the green range that we need to get on engine start. Remember, whenever we start our engine, the most important thing is to have oil pressure, and we have the upper limit in red, the lower limit in red. If the parameters would get too high or too low, this oil pressure indicator would flash in red, and we would get an annunciator. Okay, oil temperature, same thing. We have the green range and we have the red range. CHT, well, CHT in this case, this is because this is from a different aircraft. This is cylinder head temperature. It's another way of monitoring the temperature of the engine, of the cylinders. To be more specific, again, we have a green line, we have a red line, and it tells us here, I don't know if you can see it properly, the number of the hottest cylinder. Okay, in this case the hottest cylinder is cylinder number 1. TAT is the temperature, but as we said before, this is a different aircraft, so we're not really gonna be taking a look at this. You would have an EGT indicator in the Cessna 172, but the indication would be exactly the same. Then we have the fuel quantity indicator in gallons. Okay, we have 0. Then we have the yellow range. With the yellow range, this means, dude, you are in reserve, just like in the car. You are running out of fuel. Maybe you should consider landing. Okay. We have the right indicator, the left indicator, and they both move. Okay, and if the fuel gets too low, you're gonna get an oral warning that is gonna tell you, advisory, you have a problem. You're running out of fuel. Okay, now we have here the electrical. We have the main and the essential bus. Okay, the main bus with the bolts, and then we have the batteries with charge or discharge. Main battery, standby battery. In this case, both of them are charging at an amperage of plus 110. As I said before, this is not from the Cessna 172, but the display is going to be the exact same. In this page right here in engine, you can get more information about the engine, for leaning the mixture, for more precise fuel calculations. But this is really not the point of this topic, of this explanation, as it is pretty advanced. You will get it the longer you fly. You don't really need it to step in a Cessna for the first time. The last part of our panel is the rightmost part of it. Here we can find two systems. We can find the communication systems and the navigation systems. For the sake of this part of the course, we are not going to go into deep detail in how the systems actually work, on how to operate them, but the presentation in the cockpit. We will leave that for further sections such as the normal procedures. Alright, let's get started. So these are the radio panels that you can find in the rightmost side of the cockpit. We're just going to be taking a look at them, and we're just going to be seeing how to use them. Okay. In the right side part, we can see indicators. Okay, these are radiomagnetic indicators. They receive energy from ground stations, and they're going to display your position relative to these stations to be able to navigate in IFR, in instrumental flight rules. And all these are the radio stacks, okay, or the radio panel that we can select. The most important for us, I will tell you now in a bit, are these four right here, because they are related to communications. As I said before, that is basically what we are going to be doing in a visual flight. Also, this one is really important here, is the transponder. Basically tells the controller where we are, our altitude, and basically what we're doing in the air, so it makes everyone's job way easier. The first one up here is the audio control panel. Okay, that's gonna be making us able to select the audio. Don't worry, we will talk about it in the next slides. The second one is the autopilot. As I said before, not really a big deal, don't worry about it. This one is going to be your radio selector. This one is more important. In the further section, we're going to be talking about how to operate them. It's actually in the section 5.3 if you want to take a look at it after this one. In the electrics section, you're going to be seeing this radio stack again, and you're going to be seeing how to operate them. This is to operate radios 1, okay? This is to operate radios 2, and that is for the DME, that's the distance measure equipment. Then we have the ADF, that is for tuning NDVs, non-directional beacons in the ground, and the last is the transponder. Okay, as I said before, then we have these indications that are for IFR, but we are not really going to talk about this. As I said, go to section 5.3 if you want to know more about communications and avionics, because there are going to be a lot of explanations on how to work and how to operate radios for a VFR or an IFR flight. Now, as a final activity to finish up this lesson, try to find the names for the different levels in this diagram extracted from the CESSNA 172 SP manual. Try to locate some of the instruments we have taken a look at. Are you missing any? Do you see some instruments you don't remember to have seen in the presentation? Well, if you do, comment your answer in the forum, write it down, talk it with some of your colleagues, but basically this diagram is going to help you find the most important controls, the most important instruments, and basically become confident with the cockpit you're going to be flying in. It doesn't matter if you're going to be flying in a Garmin or glass cockpit or in a basic cockpit. The most important thing is that you know where everything is. If you step onto the cockpit and you look around and nothing seems familiar, you're going to lose a lot of time trying to locate yourself. So, as a personal tip, take a picture of the cockpit you're going to be flying in. There are a couple ones that you can download in the documentation section. Take a look at that and try to locate the most important instruments. Anyway, that's it for this lesson. See you on the next one.